All right, good morning. Thanks for joining us today. We're going to talk about how to connect to Gnarly data sources. My name is Arthur Gildenegg. I'm a product manager here at Tableau, and I focus on data connectivity and big data.
And I'm John Q. I'm the feature team lead for the connectivity team. I work on a number of different data sources, connectors, sort of working on security, making them a bit more enterprise ready, well tested, that sort of thing.
So why are you here today? So before I started Tableau, I was a Tableau customer, and there were all kinds of things I wanted to be able to connect to and couldn't. Right? There were databases that we used internally that we didn't have named connectors for. There were internal web services I wanted to connect to that I had to write code for and would have to drop to a file or have to use a data prep tool to push it into a database. That was problematic. We worked with partners who had web services. There was just an array of sources we didn't connect to, and I wanted to know how to connect. And so this session is really about how do you connect to those things that we don't have native connectors for.
But first, I'll talk a little bit about named connectors, sort of what makes them important. What do you need to sort of work with us to basically build a named connector? What do we like? What do we dislike? What are some challenges that we face with different sorts of data sources? This is the big blue box when you open up Tableau. Hopefully everyone here is familiar with it. This lists all of our named connectors. And there's actually a lot that goes on behind the scenes to make this happen. There's lots of tests, there's lots of performance additions, lots of different things, and I'll get into that in a little bit. But this is kind of, to become a named connector is actually kind of a long process. It involves sort of a lot of work on a number of fronts. And so talk a little bit about that. It's been growing over time. The graph is to the right and up. That's always good. And if you look at our support, though, so this is some data from DB engines, and it shows sort of the DB ranking of different data sources. The size of the box is essentially the importance of the data source. And in orange, we have what our named connectors are. So we support the big ones, the Oracles, the Verticas, the MySQL, things like that. But we also have a number of gaps there over in blue. You see at the top there's MongoDB. And there's some reasons why those are not yet named connectors. We're going to talk a little bit about how you can get data from them, and we'll talk a little bit about what you need, what we like about those things, or why they're not named connectors yet. First, a little bit about how Tableau works. You're working around in a viz. As you're creating that viz, you're creating VizQL. That was mentioned in the keynote earlier. VizQL is then translated into the analytical query language. And this is a part that most people don't see. But essentially, it's the abstract SQL representation of what we want to execute across different data sources. Maybe it includes the joins. Maybe it includes the concept of, we want to take a particular average or use this particular calculation on this one field. And then it goes down to sort of the layer that we're at, which is the connector layer. And we essentially go back and forth. We communicate upwards with AQL and down with the driver or with the data source to sort of figure out how to best use that data source. So one of the things we might do is we might also do sort of like the last mile optimizations of our queries against that data source, sort of choosing count big instead of count in certain circumstances, performing the casting, things like that. We handle the security there, whether you're using SSL, whether you're using Kerberos or SAML. That's a big part of the connector world, making sure that those things work well. Looking at sort of protocol optimizations, what the actual wire protocol is. We spend a lot of time in Wireshark looking at how these things are performing, under what circumstances they can fail. Underneath capabilities, we've got, that's sort of what we communicate upwards to AQL with. We basically, we express to the abstract query language sort of, yes, this data source supports temp tables. or it supports, select into, supports LOD expressions. And that allows the rest of Tableau to basically generate the correct queries for that data source. And then that last mile dialect, sort of the, last bit of transformation there. This is a breakdown of different types of data sources. And it's a bit of an explanation as to why something is a named connector and why something is not a named connector. Tableau handles relational data and OLAP cubes really well. Our first data source in Tableau was actually an OLAP cube. We understand how to generate SQL queries, we understand relational data, we understand how to query it, we can handle a lot of that really easily. It gets a little bit more complex when you move into some of the sort of other data sources. So time series data sources are an interesting one. I used to work for a SaaS company. I spent a lot of time in operations, a lot of time on a pager, and most often when something went wrong, or even when something was not wrong, I'd be looking at time series data. And I'd be really heavily focused in on some particular graph, some particular metric. Maybe I'm looking at CPU metrics, API calls per second, things like that. Probably the most popular time series database, at least in sort of operations sense, is Graphite. There's some other things. InfluxDB is popular now. But time series can also come in other forms, like KDB. This is often used in the financial sector for financial information. You've got stocks streaming in at sort of a rapid clip. Tableau doesn't handle these very well. Most often, they are sort of presented, they can be queried in a relational way, but the challenge here is making sure that we can handle the implicit time component of the time series database in a really coherent way. So, when you're querying time series data, you're really looking at sort of the last week, last day, last minute, and you want that to be sort of a continuous rolling window. With the sort of the change, with the addition of Hyper, we're starting to address more streaming use cases. We're starting to address some of these problems, but this has been a problem for a long time. How do we actually deal with that implicit time component and make sure that you can naturally interact with that data? Document stores. Document stores are another big effort at Tableau. This includes MongoDB, Elasticsearch, Couchbase, things like that. There are a lot of existing ways to interact with these data sources through Tableau. For instance, in Couchbase, you might create sort of essentially a materialized view, and then you connect using ODBC to that. But we don't have a way of directly connecting to a lot of data sources and being able to sort of infer that schema and then execute analytics queries. A big part of that is because document stores, they're not built with query engines that support these types of queries in the first place. They're built for fetching or setting very specific objects. That said, there's a number of document stores which are building a lot of those layers on, those query engines. They sort of recognize the value of being able to expose this data to BI products. And we see that really improving. But from the Tableau perspective, one of the really interesting things that we're doing is around schema inference. So before we can execute a lot of these queries, we want to make sure that we can essentially infer the schema off of a document. What are sort of the notable elements? How do we sort of guide the user towards understanding and pulling out the dimension data, the measures, those sorts of things. And that's coming about with the JSON connector, which Arthur's going to talk about. And the last one is a fun one, graph databases. These are used a lot in fraud detection. Certainly you can do social media analysis with graph databases. It's a lot of fun data, can be stored in this style of format. But if you really want to troll people at Tableau, ask them why there's no network graph. Ask them sort of why we can't even naturally represent the data that a graph database stores. So I think it's really, we like to bring this up. We talk about it all the time because people are using a lot of graph databases. They're using Neo4j. And there is ways to get data in, and Arthur will talk a little bit about that. But what we like to do at Tableau is we would like to sort of guide the product towards something where you're able to naturally work with the data as it is stored. So within a graph database, you expect to see nodes, you expect to see a network, you expect to be able to interact with it in a sort of a network way. So that's an ongoing process, an ongoing effort. We don't want to just sort of get the data in, we want to make it easy to use. The other challenges around graph databases, the query language, Neo4j uses Cypher. It's very, quite a bit different. There's some different workarounds, but it's definitely a big challenge. And so let's say you want to get a name connector into Tableau. This is sort of the Tinder profile for what we like. What's our swipe lefts and swipe rights? Obviously, we consider whether or not it's a popular data source. But the most important thing to Tableau is having a really good working relationship with a database vendor or whoever is surfacing this data source. We want to make sure that we can connect with engineers because we encounter a lot of challenges down the road. I mean, especially the documentation around security, Kerberos, things like that is often very difficult to parse unless you're actually talking to the developer who implemented some of that functionality. And so it's really important to have a really good working relationship at sort of the engineering level. It speeds up development incredibly. The other thing is Tableau in the last year, we've come up with a number of verification tools, a number of new things, one of which, the TDVT, is going to be open source soon. And this is a tool which essentially runs through a suite of queries that Tableau generates and needs to generate, and effectively validates a particular data source against the types of analytical queries that we like to make. That is also complemented by some of the TDC work that Arthur will talk about, and also a new thing, data-driven dialects, which is eventually going to come about. So basically, allowing further tuning of that connection. We definitely want to work with database vendors and folks who can integrate those tools into some of their processes. Because a lot of the time I spend is on security issues, Kerberos and SSL, we really like clear documentation. We like a well understood way of connecting through Kerberos. There's a lot of and in SSL, there's just a lot of variations out there when you look at the different data sources. And we definitely prefer consistency. We don't like sort of unexpected behavior in a lot of this. It's funny, like whenever we do add SSO support to a data source, it's like, 3 months of research and 4 lines of code. And that's basically how it goes over and over again. A lot of Wireshark, a lot of testing. It's just it's interesting. The other thing is sort of on the swipe left side. I want to talk about platform support. We mentioned Linux support in Tableau Server is coming out. This is a big deal for our team, so we're spending a lot of time moving over data sources to Linux. One of the things that we are trying to do as we move towards Linux is to make the install experience and sort of the overall administration experience really clean. If you think about Tableau, we support a number of different data sources, and we host these data sources within our build environment. We run like 10,000 tests per week on them. We have to manage a lot of drivers. We have to manage a lot of systems. The easier it is for a database and the easier it is for a driver to be managed within an enterprise environment, the better it is for us. So one of the things with the Linux support is we've taken the time to sort of really spell out kind of what we like. Really, if you're on Ubuntu, you should be able to type apt-get install, Postgres, and well, you can, but not with a very specific driver and things that we like with the certain patches. But we like, you should be able to move through it very seamlessly. And if you look at sort of the Windows ecosystem and some of the other things, it's much more of a hodgepodge. In some cases, database vendors have treated the driver development as sort of an afterthought, and they really haven't invested enough into that experience. And you have to realize, a lot of people, the first thing they have to do when they open up Tableau to connect to their data source is they have to download a driver. They have to kind of go through that whole process. And making that as seamless as possible is just a really important thing to us. And then the other thing is if you want to integrate with us, if you want to talk to our team, reach out, talk to Arthur, just go ahead and give us a call. We love to talk to, people who want to add named connectors.
Okay. So you open up Tableau and you go to connect to some data source, Elasticsearch, for example, and there's no Elasticsearch connector. What do I do? I experienced this many times when I was a customer. So we're going to talk a little bit about what options are available. You're not going to walk out of this as an expert in those, but I want to help you understand the thought process that you should think through, depending on what you want to connect to. Okay, so before you get started, the most important thing is know what you want to get out of that data source. It's really easy to say, I want everything out of Elasticsearch. It's a big problem, as opposed to, I just want to get this collection out of Elasticsearch. It's a little bit more manageable. So think about what's most important. If it is most important to get everything, then we'll have different recommendations that if you want to pull just one thing out. Second, get to know the data source, right? As John mentioned, when we build a name connector, we do a lot of things to customize the dialect and the security. So you download a driver, you open up a connector, and you're just connected, right? If you're trying to connect to a data source that there isn't a name connector, you'll have to get familiar with it. How do I query data? What kind of data do I get back? Do I get a table? Do I get a JSON document? Do I get XML? Do I get something else proprietary? These are all really important aspects when you're going to connect to a data source through Tableau. And third is, you probably aren't the first person to encounter this problem. There's probably other people that want to connect to this data source. And so look out in the community and see what other people have. Like if there might be, for example, a web data connector that's already been created that you can use. There are companies that build drivers that can help you connect to all kinds of different data sources. There's also an open source community where you can use things within Python, for example, to more easily access some of those data sources. Okay, so I listen to a lot of audiobooks. A lot of audiobooks. I've been a subscriber to Audible for a long, long time. And let's say I want to know what books I have. I can go onto their website, I can try to copy and paste it into Excel and then clean it up. But on my phone, in my app, is actually a SQLite database. And it has all this information about all the things that I listen to through Audible. So let's say I want to pull that data out. What can I do? Well, the first thing I can use is other database ODBC. Who's used this option? Anybody? Anybody? Yeah. This is like the first place to go, right? If there's a driver out there and you can connect to it, it's awesome, right? Somebody's already done the hard work to figure out how to basically use a standard interface to go ahead and connect to your data source. I pop open something like this window right over here, and if I read the documentation, I can see if there's special things that I need to pass, right? If I want to run an extract, for example, I can say, hey, use a fetch size of 100,000 so I can pull a really fast extract from it. So why would you use this? The first one is that it's the only option we have today that supports both live and extract modes. So if you're using a fast database, right, let's say you have an in-memory database or a GPU database, an analytical database, some sort of massively parallel processing database, Tableau is going to scale and be as fast as that underlying data source is. So if you have billions and billions of rows and that database scales to billions and billions of rows, it'll be that fast, right? But you can also switch to an extract if you'd rather do that. So to do this, you need an ODBC driver, you need Windows, and you might need to use a TDC file. Who here knows what a TDC file is? Anybody? A couple people. Who's used a TDC file? Okay, a couple. Many of you probably use a TDC file and don't even know it. If you use other ODBC, a lot of partners actually, if you have Tableau installed and you install a driver, a TDC file gets placed in your directory because somebody's already done some of the customizations, right, to help make that experience great. So we'll talk about that in just a second. And then where do I get a driver? Cool, I know I can use other ODBC, but where do I get it? First place to stop is the Datasource vendor, right? Go to their site, download the driver. But let's say they don't have a driver. You can also go to driver vendors, people who specialize in building drivers to have a really great experience. They also offer drivers that can help get you started. Okay, so we talked about how Tableau works. Let's talk about how Tableau works with other ODBC. So you start with the viz. You're doing things on your viz. We create VizQL. That gets turned into AQL. See if I can lean forward without falling off the podium. You're going to add something here called a TDC file. It's a Tableau data source customization file. And it does something in this whole process. So Tableau isn't already pre-tuned to work with this particular data source. It doesn't know this data source, so it has to have a conversation with the driver. Hey, what do you support? Do you support these data types? Do you support date? Do you support date time? Do you support these date time data types? And through that conversation, we sort of infer what kind of experience can you have, right? So if you connect, Tableau will actually tell you, hey, you should probably run an extract, right? This data source doesn't support enough. If you're working with a great driver and a good data source, you won't even see that message. Tableau will go, you can have a great experience connecting through other ODBC. What the TDC file does is it actually overrides or adds more information back to Tableau. So for example, the ODBC spec, right? So the ODBC drivers are just a standard way to be able to talk to a database. The spec itself doesn't say anything about creating temporary tables. And Tableau creates temporary tables all the time for lots of different reasons. For performance, if you're creating a quick filter, we might create temporary tables. If you're using LODs, we might create temporary tables. We do it for all kinds of things. Same thing with subqueries. But the ODBC spec doesn't have a way of telling Tableau, hey, I support temp tables, or I support subqueries. So we give you a TDC file so you can override that. You can say, hey, I know that SQLite supports temp tables. I know it supports subqueries. I know it supports this type of temp table creation. And so that's what it's really about. And this applies for both Windows desktop, and you can deploy it to server. And it really looks like this. So a TDC file is just an XML file. And what it says is, hey, I'm connecting through generic ODBC. That's sort of our internal way of saying, I'm using other ODBC. And the next thing it looks for is a driver name. So SQLite ODBC driver. If you open up your driver manager, you look at the driver, it'll actually give you the name. Don't fall off the podium. So it'll actually look for that particular driver. And it says, hey, if you're using generic ODBC and you find this driver, apply these customizations. Right? So the first one here in blue says it's cap, which stands for capability, cap create temp tables, value equals yes. All that says is, hey, when you connect using this driver and generic ODBC, you can create a temp table. We have other things here like the ability to do a select into right here and select into top. So if we want to say, hey, just create a temporary table and only put the top 5 elements, top 10 elements, you have the capability to do that. So we can create faster SQL for that database. If you go online and you search for Tableau and TDC and SQLite, there's a whole tutorial that will walk you through this process, show you all the TDCs that we have, and will help you connect through SQLite. So when I was a customer, I was a little intimidated by this. I was like, I'm going to write an XML file. I have to put it on a driver, or I have to put it somewhere on my desktop. This is actually what we use at Tableau. When we build a name connector, these capabilities are things that we turn on and off. So we're really giving you guys the opportunity to affect how the data source works in very much the same way that we do. And as John mentioned, that's only one part of the equation, right? It's around capabilities. The next thing are around dialect. How do I translate an average AVG to maybe it's sum divided by count? Those types of things we're looking towards supporting, giving you guys more power to do that in the future. All right. Anybody know what this is?
That's a windmill blade.
It's a windmill blade, yeah, exactly. So these are made to make these, and I can find information about these on this. Right? So the Austin data website, hosted by Socrata. So I can go here, I can download an Excel spreadsheet, I can put it into Tableau, I can start analyzing it. But if I have some sort of data that I want to share with my whole organization, or I don't want to have to download an Excel spreadsheet every time, there's another option. The other option is the Web Data Connector. Who's written Web Data Connector? Okay, so a Web Data Connector is a great way to connect to data that you can get to at a URL. So if you work with partners or customers and they make data available to you from some URL, this is the place to start. Why else would you use it? You can really craft the experience for your customers. Right? And I'll talk about what that means in just a second. It's also, I like to call it live-ish. We say this live and there's extracts. Web data connectors are live-ish, which means I connect, I see a list of tables, I pull them over, or I open that viz, it's gonna start extracting all of that data when I connect. So it's not like a scheduled extract, it actually will download as I connect. Okay, so what do I need to know? I need to know a little bit of JavaScript. And I want to emphasize a little bit of JavaScript. I'm not a web developer. I learned a little bit of JavaScript to write web data connectors, and I've written 4 or 5 of them. Some of them take me an hour, hour and a half. So it may look a little intimidating. We'll walk through a little bit of code. It's really straightforward, and there are great tutorials online about how to use it. So the other thing you need is web server. If you want to share this with other people in the company, you just need a place that you can post the web data connector so other people can get to it. All right, so how does this work? So in Tableau, there's a button right here called the Web Data Connector. You're just going to go ahead and enter in a URL, and you'll see this experience over here. You'll be able to, you see a table, right? So I connected to the renewable energy data on the Austin website. I pull that table over, and I can actually see the data itself. That's just data coming from a URL that I've basically formatted so that it looks like a table. It looks like I'm pulling from a relational database. And what really happens is, in Tableau, I connect to the Web Data Connector, I ask for the data, and the data just gets sent back and stored as an extract. And again, there's tutorials, but there's also a great community portal. So if you go to our GitHub site, has anybody been to the GitHub site? A couple people, you should check it out. They're releasing all kinds of really great stuff all the time. One of the great things is you go through your first web data connector. You're like, cool, I built my first one. Now I want to see what other people are doing. This is a great place to see what other people are doing. And for example, Elasticsearch, someone's actually built an Elasticsearch. So if you need to connect, you'd start there. All right, so what's the thought process of building a web data connector? After I know my data, right, I know the URL where my data is going to come from, I have to define the schema. I have to know what I want from that data source. And so that's what's happening here. Actually, I'm going to come down here. Feel a little too tall up there. It's dangerous too, that's right. So what's happening here? Basically, I've defined all of the columns that I want, right? The category, the unit, the fuel, the capacity, the year, the expiration. And then I also have a table schema. So I'm just saying, here's what I want from that data source. And here's where I can craft that experience. First, I can say, hey, capacity, by default, treat it as a measure. I know it's a measure. It should show up in the bottom left-hand panel. Let's treat it as a measure. Next, I can also say, you know, year is just a number. It's not a date. It's just a number. It's 2011. It's 2003. Tableau is going to go, it's a number. I know what to do with that. I'm going to treat it as a measure. But that's not what you want. You want to be able to slice that year as a time series, right? So I can actually say, hey, by default, treat it as a dimension and make it be continuous. So I can craft how that data should be treated in Tableau. All right, so next, I'm just going to go to the URL itself, which is right here. I'm going to walk through all of that data, and I'm basically going to map it back to what I defined on the previous screen. I'm going to say, hey, I have the category data. It's located here in that URL. Push it there and push it into an extract. And last but not least, I have to tell Tableau when to get this process started. So I put a button over here that says Get Renewable Resources. And I just say, hey, register the connector, and when I hit this button, kick this process off. Okay, so that's one data source. That's one table. Most of us deal with stuff that's a lot more complicated than a single table, right? So there's a lot of options for customization, right? We talked about the type and the column role. You can change things like the default customization. If you say, hey, this should always be count distinct, you can specify that. If, for example, you have 50 tables you need to be able to access, you can enumerate all 50 tables on the left-hand side, and anyone connecting, it just looks like they're connecting to a database. The other thing that just came out is something called a standard connection. So if you're dealing with multiple resources that you want to join together, that you know lots of people are going to need to join together, and you say, I really, really don't want to teach everyone in the company to join these 3 tables together, a standard connection lets you define the joins that you want to see between those tables. So if you have sales data, and you have salesperson as another table, and you have location as another table, you can define within the web data connector, those joins should be there by default. And somebody just pulls that object over, and Tableau will just create those joins for you. So it's another way to really craft that experience. I'd encourage you to go out to the GitHub site, watch it all the time. Things are coming out. Actually, while I was preparing for this talk, I was like, oh, there's like 3 new things I get to add to my presentation. So keep up on that site. Okay, so I listen to a lot of music. I also listen to a lot of podcasts. I'm coming to TC, and I'm going to see if I have anything fun to talk about, because I listen to a lot of podcasts. I might not be fun at parties. It's hard to say. And if I want to look at my iTunes library data, there's an XML file. Cool. So I can look at what I listen to. I can see what genres I listen to, what podcasts I listen to. So it's an XML-ish file. It's not a standard XML file. I know a little bit of Python. So there's another option for dealing with files. There's the extract API. Who's used the extract API? A couple people. Cool. So why would you use it? Simple connection experience. Anyone who opens it up, it's one file, pops up, and there's no joining you have to worry about. It's all done for you, right? It's all done for the consumer. It's also push flow, so you can schedule something to actually occur. That means if you need to pull data from an operational system during off hours, you're working with a DBA who says, don't run live queries against this. This is a great option. Also, if you're connecting to non-relational data, if you're connecting to a database that stores XML files, you can basically pull that data out, map it, keep it in an extract.
This is what you use for a cloud source?
Oh, for a cloud source?
The extract API?
Yeah, you can use it for a cloud source. Yep, definitely. You can also use the web data connector for cloud sources too. It's also really helpful if you need fast queries on a large amount of data or on a slow database, right? So you might be touching databases that are optimized for operational purposes. They're not fast columnar databases or in-memory databases, for example. This is a great way to say, I'm just going to pull all this data out. I'm going to keep it locally. I'm going to refresh it on a regular basis. This is a great place to use it. Again, here you need to know some Python or some Java or C++. I don't know Java or C++, so I'll show you some Python. And you have to make sure that you can connect to that data actually using that language. So let's keep going with the iTunes example. So somebody's done the hard work for me, and there's a library called PyITunes, which will help standardize all the data for me so I don't have to worry about this XML file that's not completely standard. I import things like the Tableau SDK, which you can get from our GitHub site. And then I start saying, all right, so what do I want to call this extract file? I should have called it fun at parties, but I call it itunes.tde. And I basically say, what do I do? If I run this thing and there's already a file there, do I get rid of it? Do I append to it? So this is where you have a little bit more control. In this case, I said, just get rid of the file. I don't care. My iTunes does not change that often. Next thing I have to do is define the schema. So I have to know what I want, right? So I want to know things like the artist, the name, the year, the genre, how long the song or podcast is. And again, I'm going to go through and just get the data and push it into an extract. In this case, all I'm doing is saying, it says 0, 1, 2, 3, 4. And it's just mapping it back to those same fields that I defined in the schema earlier. So I have to know my data, and I just have to be able to map it back to the file that I want to be able to provide to a customer. Okay, so that's the extract API. what do I do, let's say, if I have JSON and I don't know the structure of my data? I don't always know, right? When I was a customer, I would get JSON data and I had no idea what the structure was. I'd try to pretty print it. I would see that it would have all kinds of different nesting and structures and arrays. I'd pass out. I'd wake up a little bit later and I'd try to do it again. And so here's an example of fuel station data from the National Renewable Energy Lab. Sorry, it takes me a little while to remember that. And this is a JSON document. And it has sort of 4 distinct parts to it. I have the fuel station data right here in pink. I have credit cards that are accepted right here, so MasterCard and Visa. I have the address, and then if they have compressed natural gas, it tells you the PSI level. And my first thought was, what is that? So it's an array of arrays. What do I do with that? How do I analyze this data? If I opened up the extract API, I would have to understand this structure first before writing something. And if I do, great, I can go right to the extract API. If I don't, the other option is to use our new JSON connector. Anybody use the new JSON connector? Awesome. Okay, so I'll tell you guys about it then. So the new JSON file connector, you don't have to know any code. Basically, you open up it's available in 10.1, so it just came out. Don't feel bad if you haven't seen it. It's in 10.1. I'm going to go ahead and just point at a JSON file. We're going to scan that document, the first 10,000 records in that document, or objects in that document, and we're going to infer a schema. And so that's what you see right here. So you see the same things, the fuel station list in pink, the cards accepted, blue, and the address data. So I didn't have to open up the JSON file. It's already scanned and inferred the schema for me. And I can then pick, well, what do I want to analyze? In this case, I said, I don't really care about compressed natural gas. I want to look at everything else. When I click OK, we flatten all that data out so you can analyze it in a fast extract. But then we also keep all that same data in the same hierarchy when you're analyzing it in Tableau. So if you have a brand new file, you don't know the schema, you're not sure what you want out of it, I would start with the JSON file connector. It'll help you understand the data, and it might be exactly what you need. So not all data, not all JSON data is local file data. We know that. We're investing in how do we help make semi-structured data more of a first-class citizen in Tableau. If you have local files, you can use them as is. If you have data in a web service, you just need to save it to a local file. Then you can drag it over and start analyzing it. Or if you're dealing with a document database, you can export it to a file and start exploring and analyzing that data. Okay. I'm not going to fall. Okay. All right. So we talked earlier about the 5 types of databases. Do you have a question? JSON B? P. Can you
read both JSON and JSON P data source?
I'm not familiar with JSON P.
JSON B, the binary.
No, P is full.
Yeah,
The package.
no, I do not think so. No, it won't. In this case, this is just regular JSON.
It's just regular. If you have an example, maybe we can talk afterwards.
Yeah.
That'd be great. Cool. So we talked about the 5 data sources, types of data source in the beginning. So what do you do with these 4 tools that we just talked about? So the first thing I would start thinking about is schema stability. Do you know what you want out of that system? So if you're dealing with JSON data, I would start with the JSON file connector. If you're not, you're dealing with XML, I would spend some time to really understand what you need and how stable that schema is that you want to pull out. The second thing is to think about data size. If you're dealing with terabytes and terabytes of data, and you're dealing with a fast database, then I'd look at something like other database ODBC. Look for a great driver that you can connect with and that'll be fast. And then also look at how much SQL support there is. So a lot of data sources, like let's say Graphite, don't support SQL. Right? You can connect to files, you can connect to a URL, and in those cases you might think about, hey, a web data connector is a good fit for this. So let's talk through the 5 here for a second. So again, if you're talking to a relational database, right, so these are where data is rectangularized from the beginning, everything's stored as tables, I would start with an ODBC driver. That's how most people will connect. There's a great ecosystem of people building drivers. I would start there first. If you're connecting to OLAP cubes, like Kylan or Kivos or AtScale, these are these new OLAP on Hadoop solutions. There's sort of two options. They're either going down the ODBC path, saying, hey, let's build an ODBC driver. We'll teach our cube to be able to speak SQL instead of MDX. I'd start looking down that path. Other people have also had some success connecting with Microsoft Analysis Services, our connector for that, because it's a sort of a standard XMLA type connector, MDX connector. But again, I'd look to the vendor you're working with and say, hey, what do you recommend? How do you best recommend connecting through Tableau? If you're doing something like time series, Graphite, or KDB, if the data set's small that you need to pull out, I'd think about building a web data connector, a really targeted, careful web data connector. Companies like KDB are working on building their own driver right now, and you might also look at their ODBC driver to connect to it. If you're dealing with documents, like iTunes, because I know you all want to analyze your iTunes data like I did. You can look at the Extract API. But if you're looking at MongoDB or Elasticsearch, Couchbase, Dynamo, think through those same things. Do I know what I want out of that schema? If I don't, I'd export the data and start analyzing in the JSON file connector. If you do know what you want out of those data sources, look at other options, right? Is there an ODBC driver that can be used to connect to it? Does Mongo provide some sort of option to connect with? Do I know what I want and it's stable and I'll just write an Extract API to pull all that data out? Same thing with things like Elasticsearch. You can look at, hey, there's a web data connector on the community portal, and I could just start experimenting with that. Does that get me what I need? And if it doesn't, look at extending that. Same thing with graph and network databases. Those are more likely down an extract route. You're going to have to do a little bit more jiggering to try to get that into the rectangular format that Tableau is going to need to consume. So last but not least, if you have an idea for a connector, if you say, yeah, I can do that, but I really, really, really need a name connector, let us know. Talk to your account manager, talk to us after this, go and vote on the Tableau Ideas Forum. We pay attention to this a lot, and so we see what people are voting up and voting down. So let us know. This really helps us prioritize. Okay, so we gave you just a quick overview of 4 different tools to get started. If you say, hey, I think a web data connector is the way I want to go, there are sessions out here that you can look at, right? Writing your first web data connector. There's more advanced web data connector topics. These are really great talks. Also, if you're like, relational databases, I want to know more about how relational databases work, there's a database primer that Isaac is talking about, and it's great. Also, this class is tomorrow, so if you think anyone else should see this or you guys want to see this again, let us know.
It's in the other building, the ACC or the Convention Center.
That's right. And finally, please rate us. Let us know if this made sense, if this works, what other content you're looking for. Are there any questions? Okay.
Come
Well,
on,
thank you,
guys. Questions? All right.
All right, well, thank you guys so much.